We do this 100 times a day, right? Tapping out a message, attaching a photo, clicking a link, and just hitting send. It feels totally instant, like magic. But what's actually happening in that tiny sliver of time is one of the most incredible journeys you can imagine. Today, we're going to follow that journey, step by step. So yeah, what is going on in that split second between your click and your message popping up on a screen maybe halfway across the planet? Well, we're about to peel back the layers and trace the exact path your data takes from your screen all the way to its final stop. All right, so the first thing you gotta wrap your head around is that your message doesn't travel in one big chunk. It's not like mailing a letter. Before it can go anywhere, it has to get prepped for the trip. It has to be packaged. Your computer takes your email, or your photo, or whatever you're sending, and it chops it up into thousands of these tiny little manageable pieces. We call them packets. Think of it like this. If you wanted to mail a giant Lego castle, you wouldn't send the whole thing, right? No way. You'd break it down into individual bricks. It's just way easier to ship that way. Now, each one of these little packets has two main parts. You've got the payload, that's a small piece of your actual data, one of those Lego bricks, and then you have the header. The header is basically the digital address label. It's got all the critical info, like where it's going, where it came from, and which message it's a part of. So, how do all the different computers and devices along this journey know what to do with all these packets? Well, they all agree to follow a shared set of rules. These rules are called protocols. The best way to think about a protocol is like the official language, or maybe even the grammar of the internet. Without these rules, it'd just be chaos. Nothing would work. And these protocols cover everything. I mean, they dictate the exact size of each packet, the timing of when things are sent, how the information is encoded, literally every detail. So every device, from your phone to some massive server in a data center, is speaking the exact same language. When you boil it all down, this whole complicated process comes down to the three basic parts of any communication. You've got a source, that's your device. You've got a destination, the device you're sending to, and you've got the channel, that's the path the message takes. All these packets and protocols, they're just the incredibly smart way we manage this on a global scale. So let's look at the first part of that channel. Okay, our packets are all bundled up and ready to go, but their first big challenge isn't crossing an ocean or anything. Nope, it's just getting out of the building. First, they have to get through your local network. Your local network is probably one of two kinds. You have a LAN, a local area network, which is all wired up, or a WLAN, a wireless local area network. You're almost certainly using one of these right now. It's the network that connects all the devices in your house, or your office, or that coffee shop down the street. And you can see the difference right here. On one side, a wired LAN uses actual physical cables, those Ethernet cords, to plug everything together. On the other side, a wireless LAN, what we all call Wi-Fi, uses invisible radio waves to send the packets right through the air. But either way, the goal is exactly the same. Get your packets from your device to the next stop on the journey. And that next critical stop is the router. Your router is basically the gateway between your private little network and the massive public internet. It acts like a traffic director at a busy intersection. It takes in all the packets from your local devices and figures out how to send them out onto the wider network. It's the exit door for all your data. So once our packets get past that router, they are officially out in the wild. They've just entered the internet itself. And here's the thing. The internet isn't one single entity. It's a massive, sprawling network of networks that connects the entire planet. This is where the real adventure begins. Honestly, the best way to think about this part of the journey is to imagine a global postal service. Every packet is like a letter, and the IP address in its header, that's the unique mailing address for a specific device somewhere out there on the network. The internet's whole job is to get that letter to the right address, no matter where on Earth it is. And for most of the things we do online, like sending an email or loading a web page, the delivery is what's called a unicast transmission. It just means the packet is being sent from one single source, your computer, to one single destination. Simple as that, a direct one-to-one delivery. So how in the world does your packet find its way through a web of billions of possible paths? Well, out there on the internet, specialized high-powered routers are constantly talking to each other. They use these really complex protocols to share live maps of the network, updating each other on traffic jams, and calculating the fastest, most efficient route for your packet at that exact millisecond. It's basically a Waze for data packets.
And this really gets to the heart of what the internet is. No single person or company or government owns it. There's no central headquarters. It's a gigantic, decentralized network of networks, all voluntarily agreeing to use the same rules to talk to each other and pass packets along. Every time you connect, you own your own little slice of it. The whole system is built on cooperation. It's pretty amazing when you think about it.
Okay, so we've been talking about packets and protocols, which is all a bit abstract. But how does this data physically get from point A to point B? This is where it gets really cool. The internet isn't just some cloud. It's a vast physical thing that spans the entire globe. A lot of data still travels through good old-fashioned copper wire. Like inside one of these coaxial cables, there's a central copper wire that carries your data, all those ones and zeros, as tiny electrical pulses. It's very similar to the cable TV and telephone lines we've had for decades. But for the really high-speed, long-distance stuff, your data literally becomes light. The backbone of the internet is built out of these incredible fiber optic cables. Your data gets converted into pulses of light that bounce their way down a core of pure glass at, well, nearly the speed of light. This is why talking to someone on the other side of the world feels instantaneous.
And of course, data also flies through the air. Just like the Wi-Fi in your house, invisible radio waves carry packets all over the place. And for really long distances, these radio signals can even be shot up into the sky to bounce off the Earth's ionosphere to reach super remote spots. So yeah, from deep-sea cables to the upper atmosphere, your data travels through some pretty wild stuff.
So, after traveling through copper wires, glass tubes, and open air, and getting directed by who knows how many routers, our little packets finally arrive in the right neighborhood. Now there's just one last step: turning all those tiny pieces back into the original message. Now remember, we chopped that message into thousands of pieces, and they might not have all taken the same path to get there. One might have gone through London, another through Tokyo, but that's totally fine. That header on each packet tells the receiving computer exactly which message it belongs to and where it fits in the sequence. The device just gathers them all up and reassembles them in the right order, perfectly recreating your original message. It's like a self-assembling puzzle. So let's just quickly recap this wild journey. First, your message gets broken down into packets. Second, those packets navigate your local network to find your router. Third, routers forward them across the vast internet. Fourth, they physically travel as electricity, light, and radio waves. And fifth, they all arrive and get put back together. All of that happens in the blink of an eye. In the end, the entire internet works because of agreement. It's a massive cooperative system built on a shared set of rules, those protocols, that allow all these independent networks to act like one single global thing. It really makes you wonder, as our technology keeps evolving, what's going to be the next big rule, the next groundbreaking protocol that completely changes how we all communicate?